Here you'll see in figure 2.16, what we're looking at is two distinct soil profiles. One from grassland vegetation, one from underneath grassland vegetation, the other one from underneath forest vegetation. The big thing that you'll notice for both of these is that there's distinct horizons. The thing that's different is the location and the inclusion of, like, for instance, an E horizon. So you'll see on the forest soil, we have an E horizon close to the surface here, and you'll recall that an E horizon is a zone where things have moved out, materials have moved out of that horizon, eluviation. And so we're losing clays, we're losing oxides and what we call iron oxides and things like that, because there's typically slightly higher rainfall in these areas that allow for what we call leaching, or moving out of those materials into the B horizon. So you'll note here this B horizon, and that B horizon says B and it has a sub T. We'll find out what that means later. Well, we'll find out that there's lots of different varieties of those letters there, and they each mean a particular thing. So you'll see that we've got an O horizon in the right-hand side forest vegetation. O horizon, A horizon, very thin A horizon, an E horizon, a B horizon, and a C1 and a C2. So that's all a C horizon, but what happens here is we're able to distinguish between two different types of C horizons. We know they're both C horizons, but there's two different types of them, and so we're able to say, well, this is the first type, C1, the second type is C2. On the other side, you'll notice under grassland vegetation that we have a very thick A horizon. So we have a very thick A horizon broken up into two pieces. An A1, probably higher organic matter, and maybe a little bit of structural or textural differences, and an A2, so distinguishable A horizons. The thing about grassland vegetation is, soils underneath grassland vegetation, we'll give them a name later when we get to soil classification in the next chapter, but you'll see that you have higher organic matter deeper down. What happens is that grasslands and grasses in particular have very thick fibrous roots that turn over year after year after year. So when they do that, and when they make new roots and then those roots die, if it gets grazed, for instance, or there's a fire that comes through, those roots will die and contribute organic matter into this whole section. So that's why I have a pretty distinct A horizon that's higher in organic matter. We still have a B horizon, and that B sub T means we're increasing in clay in that horizon. Then we have a horizon here called the CB. Anytime you see two horizon designators, two master horizons, so this O, A, E, B, C, and we have another one called R, those are our master horizons. And those are the ones that we can call the big characteristics with. And then we can designate little nuances with those letters. Sometimes if we put horizons together, like this CB horizon, what we're saying is that, you know what, there's some properties that are like a C horizon and some properties that are like a B horizon. So it's not quite a pure C horizon, and it's not quite a pure B horizon. It's more C than it is B, but we'll just kind of mash them together and say it's a CB horizon. You'll notice we have three different horizons, or three different categorizations of the C horizon, deeper in the soil, each for different things. You can see the K is the calcium carbonate or calcium sulfate accumulation below. So these are some big differences between the grassland vegetation soil and how biology and biota really impacts how soils are formed.